Good morning. How is everybody doing today? So I'm going to do a very unusual talk today. I know we all work with hardware, and the hardware you probably work is phones. But I also wanted to talk about controlling hardware from your phones. And so this is what this talk is about today. So a little bit about myself. I'm an engineering manager at Brex. Today we do credit cards, but on my personal time, I do build, ride, and race electric vehicles, all sorts of stuff. Anything that has wheels on it, I will put a battery, and I will put motors, and I will do some sort of stuff to make it go pretty fast. So that's what I do. On my free time, I build projects for myself. It might be useful for others, and whenever it is, I will release it, just like open source people do. So what is today's route? So I'm going to give a little bit of context about bike modding context. So if you have ever an electric bike, you can modify your electric bike. And so a little bit about that. Talk about the problem, my solution to it, and some of the goals that I had. An introduction to Kilowatt, which is the app I'm showing. A proof of concept, how I made Bluetooth happen, how I fell in love with EAS, making it more awesome, and a little bit of why Expo is amazing. So context. I have 72 slides, 30 minutes. This means that I have to go pretty fast, so you guys will get a little bit overwhelmed by the end of this. But you can talk to me later if you want more info. So what is the victim? This is my bike. It's called a Suron. This bike can go pretty fast by stock. It can go 72 kilometers per hour or 45 miles per hour. It has a range of around 48 kilometers or 30 miles. It has a torque of 4.8 kilowatts, and it's fun guaranteed. If you really like doing dirt trails, and if you have ever done dirt bikes before, you will love this because you don't have gearing, you don't have engines, and you have instant torque. That's the benefit of having an electric car. If you have ever ridden a Tesla, you know how it is to full bottom up, right? And so it's amazing. And so why modding? First, make it your own look and feel. So this is my bike. I like doing some graphics on it and making it look like the way I like. But also, I want to have more speed. I want to go 128 miles per hour on this bike. I also want to have more range. I can have any battery I want there. And I also want to have more torque, 25 kilowatts. It's way, way more. And I can have ride tracking apps. That's why I want to mod. The controller. So the stock bike comes with that X Suron controller. That controller is only 4.8 kilowatts, and I want to go 25. If you want to go more, you have to buy a different controller. And so this is what a different controller looks like. This is the ASI BAC 8000. It's a very powerful controller. It's used for a variety of different applications. Bike is just one of them. It can go up to 48 kilowatts. That's crazy, and it's comparable to actual real motorcycles. It's adaptable to most EVs. You can install this on a car. I have friends doing like mini go-karts using this. And so it's pretty fun. You can use this controller for almost everything. It has Bluetooth LE communication, but it has a proprietary and a non-free app. And so let's start talking about the problems. What are the problems that we have? There are many. The problem number one is that to use that controller, you need a screen. And the screen absolutely sucks and saves no data. So although I can see things real time, I cannot save the data. And so this is how it looks like. The screen or the console is responsible for controlling the speed of the vehicle. It has wrong speed numbers, which is not very useful. It has a laggy user experience, so when you change gears, it doesn't really update super fast. The software is pretty generic and not really tailored to what I want to do. The protocols are proprietary, and there is absolutely no documentation for this. The second problem is the lack of an open source or even open free or paid consumer grade app. Nobody's thinking about that. And so this is how the app looks like today. I think that the user experience kind of sucks. I don't know if everybody really understands what a bit is, but if a consumer understands what a bit is, it's quite interesting. This app is kind of messy. It's a Xamarin-based app, but it also has web stuff. So this is a web view. I don't understand some of the decisions here. And in the end of the day, this was made for technicians and not really for people like me and you. The dealers cannot redistribute this app, so whoever sells the controller cannot sell this app or give access to consumers. And so what happens is that people just like me and you that are trying to mod the bikes just can't do it. Problem number 3 is that where there are gaps, there's money. And so the way that it happens is that dealers are usually small businesses. There is no expertise to build apps. And so what they end up doing is every time you want to change a setting, they will charge you $150 to just toggle a setting on your controller. And that's absolutely ridiculous, in my opinion. Second is there's a janky remote tune process, they say, which they log it into your phone using like some sort of like team viewer style, and they kind of like change stuff in your phone, and like I don't really like that. So what is the solution? Oh, I'll build my own app, right? Great. Introducing Kilowatt 1.0. It's not released yet. It's on test flight, but I'll show you a little bit about it later. What are the goals that I had for this app? First, I wanted to have a very simple setup. It needed to be simple for people to use, and anybody in the world could use because they understand some of the basic concepts, and they should be able to do their own without like fearing making a change that will like damage the controller or make they end up hitting the bike on a wall. So I don't want that to happen. The second thing I wanted to have is a real-time dashboard to replace that janky screen. And the last thing I want to have is ride tracking, because as a good nerd, I do want to see the graphs and I do want to see the information later. And I do want to analyze, improve the performance of the bike based on numbers. So I said it's in a week, right? So first 48 hours. Protocol proof of concept. The first thing I wanted to know is like, can I even do this? Like, I know that there is some bytes going on and back and forth between the controller and the device. And so I first needed to know if I could actually make the protocol work. And so I discovered that it's using a standard protocol in cars called Modbus. So Modbus is a pretty common protocol around. And so it's good that they were using some sort of a standard. And there is a open documentation about it. So it's good because I can actually just implement the spec. The most important one for us is like reading registers and writing registers. So all of that is documented. It's just like, a sequence of bytes. You can see that the request has a function code, a starting address, a quantity of registers, and then the response will have the function code, the number of bytes, and the register value. So it's basically an array at this point, and you just like, parse a bunch of data that way. But how I discover all of that? Let me introduce you to reverse engineering apps. So as I show you guys, there was already an app available. And I wouldn't start from zero. I would try to gain knowledge from other people. The way that I try to learn knowledge is I will take the app and I will decompile it. So how do you decompile an app? Decompiling an iOS app is more complicated than decompiling an Android app, at least in my opinion. So on Android, you just download this tool called APK tool. APK tool has this command called D, and it will decompile the app into a full flat folder with a bunch of stuff. So you're going to be able to see the XMLs for Android, you're going to be able to see the bundle, and you're going to be able to see a bunch of information there. So not every app is a native Java app. React Native are not native Java apps, as in Xamarin isn't as well. So when you try to decompile a Xamarin app, you will kind of end up with this structure with a bunch of DLL files. Xamarin runs kind of .NET, so it's a different virtual machine made by kind of like Microsoft, but also like a different organization. And so I needed to decompile the DLL files. So how do you decompile a DLL file? Well, first of all, as many different things that don't use native code, they will optimize in some ways. And one of the things that Xamarin does is to compress those files in a format that is more, that is easier for the mobile device to load. And so if you try to decompile those DLLs using some sort of a tool like ILSpy or et cetera, it's not going to work. So the first thing you have to do is to use this other tool called Xamarin Decompress. So Xamarin Decompress is able to decompress those files into regular DLL files that are able to now use Visual Studio or anything to actually see the entire code base. So I had the entire code base for the app, so I could learn a lot of this stuff. And so one of the things that I discovered is on Modbus, you have this thing called Object Dictionary, which is just basically a bunch of addresses. You know what is the name of that field, that address, and what is the value that goes into that address, and what is the scale of the number that goes into that address if you want to have numbers that are like divided by 10, for instance, or divided by 45. There's various different scales. So this file is available from the vendor, incredibly, and I was able to download it or even like steal from their app and then start building my app on top of that. And so the first thing I did, I was on a flight on the 48 hours. I decompiled the app. I figured out all that stuff, and I started writing the code. But because I was on a flight, I didn't have a Bluetooth device, so I basically wrote everything as tests. So all the protocol parsing and protocol generation was all done in tests with unit tests, and I was able to verify that my results were compliant to the spec just by writing the tests. Great, so that's third day. On the third day, I'm back, but I still don't have the controller. But I knew that I needed to do Bluetooth. So how do you do Bluetooth on React Native? We have this amazing library called React Native Bluetooth Please. That's how I call it. And so it's an amazing library. And I was like, if this works, I think that my proof of concept is done, and I think they can work. But that also meant that I needed to use native modules. And if you guys are in Expo, you probably don't want to use native modules because then you cannot use Expo Go, and all the conveniency kind of goes away. But some guys were working on some cool stuff that you guys saw yesterday, huh? And I'm like, that's what I need, right? I will time box this. I'll time box this to 10 minutes. If I can get this done in 10 minutes, I will be going with that. And so how you do it? You EAS CLI, you install the package, you install like a specific config plugin, and then EAS build profile development, and 15 minutes later, boom, I have this amazing custom build of Expo Go that can run my code and can connect to Bluetooth devices. And I'm like, this works, right? Good job. Fourth day. Fourth day is the day that I realized, great, Bluetooth lists and connects to devices. So this is the very old version of the app. You can see the logo is not a proper logo. But it works. But I don't have a controller. So this is something that you will realize as you do the Bluetooth development, and I think is a very good practice for you to have. You will not always have the controller at your place, and probably you want to do something about developing without having the actual hardware. You cannot always have the hardware. So how can I test Bluetooth communication when I don't have the target Bluetooth device with me? Well, you use Bleno. So Bleno is a library for Node.js that can implement both central and peripherals in JavaScript, basically. So you can both build your own IoT device on Bluetooth LE, on a Raspberry Pi, for instance, or you can build a thing that controls the device itself. So I use Bleno to basically build my own mock controller. And so I'll be able to show you guys later of how I am doing it. But basically, I'm replicating the same bytes and bits that come out back and forth of the device, trying to make the protocol look as much as possible as reality. So this is how it looks like. It just creates a device, it advertises the device, and then it does a bunch of memory stuff and a couple of simulation where I'm just doing a sine wave to have the speed changing and have some sort of a change happening on the system. But other than this, Modbus is based on memory, so you always write and read from addresses. So it's very easy to implement this as just basically a big array where, or a big object where the keys are the addresses and the values are the values that you have. And so this is what I'm doing. Not very complicated, able to do this in a couple minutes. We're almost at the end, sixth day. I was in a stretch to finish it, and I was almost going back to be able to plug into the controller and make it work. And so this is the time to do some of the UI. All of that was working without a UI. It was all, just plain JavaScript, and it's the time now that I have to think about how I'm going to figure this out. So I kind of mocked the three things that I wanted to do. I wanted to have a way to connect. I wanted to have a way to select where you want to go. You want to have a setup screen with some of the stuff that you can change, like voltage and power, a tab bar that allows me to kind of navigate through many of the setup things that you have. And last is a dash that has some sort of a graph, and you can change the speed modes or gearings of the bike. There's no gearing, but it's just like the power level. So I found this amazing video from William where I'm like, you know what, I want to do this gauge, but I don't want to spend time figuring out the math. So what you do when you want to do crazy, great animations and you don't want to figure out the math, you go to William's channel and you just copy his code, right? And even better, you don't even change the colors, as you're going to see on my demo. And so this is the basic setup screen mocks. I had to re-implement the segmented control because segmented control doesn't exist on Android, so I did my own. Things reanimated, all the animations just work. I had a basic dashboard. Again, the colors have not been changed from William's video. I'm too lazy to do that. And on the 7th day is the day that I just integrated everything, and I had to publish it. And so how do you publish the app for the first time for everybody? Well, you just do one command. You do EAS build, profile, platform iOS, profile staging, auto submit. And the cool part is auto submit just submits the app, and you don't have to do anything. And the best part is it's pretty late at the night, and you just want to release the app. So what you do, you run this command, and you go to sleep, and the next day you just release it to beta testers. Amazing. So Kilowatt 1.0, I wanted to do a little bit of a live demo for you guys, which might or not fail. And so I'm going to start using the simulator. Let me hide this performance monitors thing. So this is the home screen. It's a little bit different from the original one you guys saw. I did some of the refactors here and I started using some of the nice features. But the basic idea is that you can add a device, and then when you add a device, you just scans Bluetooth devices, and it shows on this list. Upon connection, you can do a couple things like rename or configure auto setup. The demo mode is quite interesting. The demo mode is the same implementation of the simulator, but instead of going through Bluetooth thing, it basically mocks the Bluetooth device itself. So it's running locally within the device without me having to have the actual Bluetooth connection happening, and that means that I can develop on the simulator, and the code is shared between the simulated Bluetooth device and the demo Bluetooth device, one that goes through the physical layer and the one that doesn't. So I can test both implementations, and I can run on the simulator. Very, very useful and very important. It's kind of like a little bit of an end-to-end test as well. So the features that you have are kind of basic on, you have the setup mode. On the setup mode, you can change some of the settings. By the way, all these animations are, again, just like basically plain reanimated animations, and it's great that it just works. You can see like even like the shifting height of different rows as things appear is also like automatic. If you want to add these animations, super simple layout animations, entering, exiting a layout, and it just works. For the lazy people like me, it's great. You just like add one line of code, and the animations work. You have different tabs as well that you can navigate through. You have a couple different types of wizards that people can go through as well. This is, by the way, using state machines, if you're interested about. That's how it handles all the different transitions that you can have across the application state without doing a bunch of if and else's. So there's a couple different implementations. X state is the most familiar one. Of course, going to show not a number because I didn't do anything. And I can cancel, and I kind of reverse the changes as well, and all that is handled by a state machine. So this is the setup mode. There's also another very cool thing here. There's a dyno. So the dyno is like kind of a dyno, but it's a simulated dyno. The basic idea is like sometimes you do want to tune some of the parameters based on the feedback response you're getting from the bike. And so you can just like hit play, and live it will be collecting the parameters, and it will be plotting those parameters as a graph, so you can kind of like analyze the data and draw conclusions from it. If you want to save, you can just hit the save button, and it's going to download a CSV file that you can share to your friends, or you can share with someone for analyzing the data and drawing conclusions out of it. So this is the first mode. The second mode is the dash mode. The dash mode is the live mode that I use. So during the ride, while I'm riding, I'm having my phone always on my console, and I can use the phone to just control the bike. I can go to like normal mode. I can go to like different gearings, and there is a very cool feature of this that I can actually control this through Siri shortcuts. Change to N. Nice, right? So Siri shortcuts, React Native, graphs, animations. That's pretty cool, right? There's a lot of cool stuff here. So let me go a little bit to the talk. So I told you that I did this in 7 days or in a week, right? The proof of concept was in 7 days. But this has been so far around 350 hours of work. So how were the next 300 hours spent? So data logging and analysis was very important to me. I like to use data to draw my conclusions for things, and I think it's very important that you also do. I think that some of the talks about performance will definitely be showing you that The way that you approach performance is that you measure, you prove a point, and then you make changes, and then you measure again, and then you prove that you solve the problem, right? And so the same thing goes for bike tuning or any engine tuning. You have to have a dyno, you have to use some sort of a tool to measure things, to draw conclusions, to make changes, and to evaluate if your changes have any significant impact. So data logging and analysis were very important as part of this project. So on the dashboard mode, data is sampled at 150 milliseconds interval. And there are 10 data points that are sampled at 150 milliseconds interval. So this basically means that per hour, you will have 240,000 data points. And a regular ride that I do is like 2 to 3 hours, which means that you're already at 480,000 data points. So that's a lot of data points, right? As you all know, charts on React Native are a challenge. And I tried many approaches. I tested many different charting libraries. I tried libraries using Reanimated. They were good, but they were not good enough. I tried Skia. It was good, but it was not good enough. And so after exhausting my options, trying to put 500,000 data points on the screen, I decided that I needed to go away from JS. JS was probably not the right way for me to solve this problem. And so there is this amazing library as well called React Native Charts Wrapper. It wraps 2 native libraries that are basically the same interface. There is MP Android Chart and iOS Charts. And it provides you a nice React Native interface, but it renders an actual proper native chart using native code. And so how do you get this library to work? Amazing. You're going to see this slide like this like 4 or 5 times across this presentation because it's just simple like that. You add a library, EAS build, profile development, and you get one more of those delightful development clients with the library already installed for you. And then you just use it, and it works. It's a little bit of like, wow, incredible. I can't even believe we're living in an age. The second problem I had is SQLite. So SQLite was becoming a bottleneck. If I am to send 500,000 data points, through the bridge, you can imagine those amazing JSON streams being serialized and sent over to the bridge, deserialized, and then, all that communication going back and forth. So SQLite was becoming a bottleneck, and fortunately, yes, 450, almost like 500,000 rows going through the bridge, trademark. So I found this library called React Native Quick SQLite. And what is amazing about this library is that it's compatible with all the SQLite libraries that we have, so the interface is basically the same. But the difference is that this library is using JSI bindings instead of using the bridge. So there is no crazy back and forth and serialization of information going. So this is amazing, JSI-based SQLite bindings. And so how do you get it working? I'm going to repeat my slide once again. You do yard add, and you build one EAS, and it works. And then you will have to worry about it. There is a type ORM patch package for this. And one thing that I want to be cautious about this library for you guys that is very, very important is a learning that I had. JSI, let's talk about JSI. On the bridge, everything is asynchronous, right? Because you do have to serialize data, send over, process on the native side, and then async respond. On JSI, you are able to write methods that are blocking the UI thread. So when you make that call, you basically block running your app. And this library provides you 2 variants of functions. The first one is synchronous. And if you call the synchronous function, it's going to block your program. Your program will basically stop working for a while until the query responds. There is an async version that is the version that you should use. If you ever use this library, they will provide you a patch that you can apply to type ORM, which is the ORM I use, that uses the library but does not use the async version. And so I did change the patch on my own project to be using the asynchronous versions. And the cool part about the asynchronous versions is that on iOS at least, it does use Grand Central Dispatch to dispatch this in a thread, so it doesn't block the UI. It does not run on the UI thread. It does not run on the JS thread. And so the performance was significantly improved by just making that patch. And so the last one is the stretch goal. I using your hands when you're going pretty fast on a bike that was not supposed to go that fast, even though you're doing it, you probably don't want to move your fingers out of the handlebars because that's quite dangerous, right? And so I thought, like, what is the best thing I can do? Why don't I control the bike with my voice? Isn't that a great idea? How many times have you said, hey Siri, call something, and then you call somebody else? It should not be dangerous, but why not try, right? And so my stretch goal was to have voice control, and I'm like, oh my God, this voice control thing is going to take so much time from me, right? No, actually. There is this other library called React Native Siri Shortcut, and it allows you to actually create Siri shortcuts for your app. And so this is what I show, going into the Shortcuts app, touching into the shortcut, and then opening. You can also activate shortcuts with your voice. It's not fully Siri integration, but it is a way to do the integration. The only downside of using Siri shortcuts is that a Siri shortcut requires the app to be foregrounded to execute. It's different than Siri intents. Siri intents can be handled at background level. And so when I touched into the shortcut, you saw that it actually moved to the app. That's one of the downsides of shortcuts. But because I'm always running the dashboard mode in front of me live, that's not a problem for myself. And so how do you get this library to work? I'm going to repeat that once again. Okay, you just add it and you EAS build, and then it works, right? No, it does not always work, but it doesn't mean that it cannot work. All right, there's always a way. So this package requires extra setup, and I think this is very good advice for everybody that is trying to get EAS build to work. Sometimes you will require some additional steps to make the library work. And so one of the changes here is changes to the app delegate. You have to insert code into the app delegate to handle the intent of the shortcut itself. And so this is documented on the installation. It's on the README file. And so you just literally have to copy that line and then paste that in the app delegate. But that kind of brings me that fear of native modules once again. Like, I don't want to be changing that stuff, right? So how do you do it and still make it work with EAS? Remember that sneak package? So config plugins, React Native, BLE, PLX, like what is that? Why was that there? Well, that is what it is. This is the Expo config plugins. Config plugins are a way for you to, during the build cycle, so when you do Expo pre-build, to run scripts that will modify files in a safer way than you would do manually or doing your own bash scripts that do SCD. And so I did my own. I copied some of the existing ones, modified some of the stuff. That's copy and pasta, like very standard. And so basically, I'm using this to be able to make it work. And then after my config plugin was done, it will be eventually coming soon to the config plugins repo or somewhere else, and you will be able to do EAS build, profile development, and then you have a build that can do shortcuts, and that's amazing. Cool. I have 2 minutes left, so that's pretty good. So what's next for this project? So there are about 60 testers using Kilowatt today with the most various different challenges, both technical and also in terms of their setups. There's various different setups of controllers, of plugs, and et cetera. And so it's been really good. To me, the most important thing, and I know that I didn't have this on the slides, but I should at this point. One thing that is very important, and I see that people usually overlook this on their apps, create observability for your apps. Build Sentry from day one. Build logging from day one. To me, the most useful and important thing was being able to go and understand the customer problems by looking into the logs. So I did a Datadog integration, which basically I pipe everything from console log into Datadog. And then when a customer or a user has a problem, I am able to go through the logs and see exactly what is happening. So log search. And then this only happens in staging, so it's good that development doesn't like clutter. And so here I see everything that is happening. So I can see the session ID. I can see when the user starts something. Like in this case here, I read the software version. This user is running the firmware version 602. And I can navigate through the logs and see exactly what is being done. So I read 0, but I wrote 202. And so the write check failed, it's 0. And so I can debug the app without seeing what the user is seeing because I'm logging everything that's happening. So if there's one advice I want to give you guys is always add observability to your apps. There's nothing worse than not being able to know what is happening on the user device. The third part is, I think that the UX needs to be simplified even further. And that's why beta testing is so useful. I was able to understand from the beta how I thought the UI was easy, but it was not. And so I need to make it even easier for people. And the last thing, one of the other things is background task integration. I really wanted to have Bluetooth auto start, which is a way for you to bring the app from being dead to being alive and start ride tracking without having to open the app and start it. And so this is something that requires background task integration because the app needs to be run in a headless mode. It's very similar to how background fetch works on Expo. And of course, the last one is publishing the first release outside of the beta. And lastly, I just wanted to say thanks. The reason why I was able to make this app in an enjoyable way and so fast way is because all of these people. Like, I wanted to thank Software Mansion here for Reanimated 2. It's been a joy to work with. It saved me my time. I just add one line and animations work. I wanted to thank the Expo team for EAS, and in this case, SDK44. Even, of course, for config plugins and all the config plugins that I copied and pasted from him and just modified. William, thanks for having videos about everything animation, so I just can copy your code. And then the community, thanks for all these packages. I feature 4 or 5 packages today that were made by you guys here. And so if this was possible, it was only possible because of you all here and the impact that you made in the community. So I'm extremely grateful, and I'm sure that the community that is modding bikes around the world is also grateful for you. So thank you very much for your work.